The Earth's atmosphere is one of the most fascinating and essential components of our planet, yet it often goes unnoticed. Every breath we take, every cloud we see, and every weather pattern we experience is shaped by the thin layer of gases that surrounds our world. The atmosphere is like a protective blanket, shielding life on Earth from the harshness of space while also providing the air we breathe and the conditions that make life possible. It's a complex system that works in harmony with the land, oceans, and even the sun, weaving together a delicate balance that sustains all living things. To fully appreciate the atmosphere, it's important to understand that it isn't just an invisible, empty space above us. It's a dynamic, multi-layered system filled with different gases, particles, and energy flows, each interacting in ways that are vital to the planet's function. Imagine standing on a mountaintop, looking up at the sky. It might seem endless, stretching upward into infinity, but in reality, the atmosphere is surprisingly thin. If the Earth were the size of an apple, the atmosphere would be no thicker than its skin. Yet within this thin layer, an entire world of activity takes place, from the swirling winds of weather patterns to the subtle processes that regulate the climate. The story of the Earth's atmosphere begins billions of years ago, in the early days of the planet's formation. Back then, the Earth's surface was a violent, molten landscape, bombarded by meteorites and volcanic eruptions. The atmosphere, if it could even be called that, was a thick, toxic mix of gases like hydrogen, methane, and ammonia, completely inhospitable to life as we know it. Over time, as the planet cooled and stabilized, volcanic eruptions released vast amounts of gases into the air, including water vapor, carbon dioxide, and nitrogen. These early volcanic outgassings laid the foundation for the atmosphere we have today. One of the most crucial developments in the history of Earth's atmosphere came with the rise of tiny organisms called cyanobacteria, which appeared around 2.5 billion years ago. These microscopic life forms had a profound impact on the planet. Through the process of photosynthesis, cyanobacteria began converting sunlight into energy, releasing oxygen as a byproduct. This oxygen slowly accumulated in the atmosphere, eventually transforming it into the oxygen-rich air we now depend on. The presence of oxygen allowed for the evolution of more complex life forms, setting the stage for the development of plants, animals, and eventually humans. Today, the Earth's atmosphere is made up of a mixture of gases that work together to support life. The most abundant gas is nitrogen, making up about 78% of the atmosphere. Oxygen, which is essential for breathing and combustion, accounts for roughly 21%. The remaining 1% is made up of trace gases, including argon, carbon dioxide, methane, and small amounts of other gases. While these trace gases may seem insignificant in quantity, they play crucial roles in the way the atmosphere functions, particularly when it comes to regulating the Earth's temperature and climate. As we journey upward through the atmosphere, it becomes clear that this thin veil surrounding the Earth is not uniform. It is divided into layers, each with its own characteristics and importance. The lowest layer, where we live and where all weather occurs, is called the troposphere. This is the part of the atmosphere that we interact with most directly. From gentle breezes to violent storms, from rain to sunshine, all the weather we experience takes place in the troposphere. It extends from the Earth's surface up to about 8 to 15 kilometers, depending on your location, with the thickness varying between the poles and the equator. One of the most noticeable features of the troposphere is the way temperature changes with altitude. As you go higher, the air becomes thinner and colder. This is why mountaintops are often covered in snow, even in tropical regions. The reason for this cooling is that the troposphere is heated mainly from below, by the warmth radiating from the Earth's surface. The sun heats the Earth, and the Earth, in turn, heats the air directly above it. As you move farther away from this heat source, the air temperature drops. Above the troposphere lies the stratosphere, a layer that extends from about 15 kilometers to 50 kilometers above the Earth's surface. While the troposphere is turbulent and filled with ever-changing weather patterns, the stratosphere is much calmer. It is here, in the stratosphere, that we find one of the atmosphere's most important features, the ozone layer. The ozone layer plays a vital role in protecting life on Earth by absorbing the majority of the sun's harmful ultraviolet, UV, radiation. Without the ozone layer, life as we know it would be exposed to dangerous levels of UV radiation, leading to increased rates of skin cancer, cataracts, and other health issues, as well as severe damage to ecosystems. Interestingly, the temperature in the stratosphere increases with altitude, the opposite of what happens in the troposphere. This temperature inversion occurs because the ozone layer absorbs UV radiation, warming the surrounding air. The higher you go in the stratosphere, the more heat is absorbed by ozone, leading to higher temperatures. Beyond the stratosphere lies the mesosphere, a region that stretches from about 50 to 85 kilometers above the Earth. The mesosphere is the coldest layer of the atmosphere, with temperatures plunging to as low as -90 degrees Celsius -130 degrees Fahrenheit. This layer is also where most meteors burn up upon entering the Earth's atmosphere, creating the bright streaks of light known as shooting stars. Despite its frigid temperatures, the mesosphere remains an important part of the atmosphere's overall structure. Above the mesosphere is the thermosphere, a layer that extends up to about 600 kilometers above the Earth. The thermosphere is a fascinating and extreme environment. Here, temperatures can soar to over 2000 degrees Celsius 3600 degrees Fahrenheit due to the absorption of high-energy radiation from the sun. Despite these scorching temperatures, the thermosphere would not feel hot to a human, as the air is so thin that there are very few gas molecules to transfer heat. The thermosphere is also home to some spectacular natural phenomena, such as the auroras, commonly known as the northern and southern lights. These dazzling displays of light occur when charged particles from the sun collide with atoms and molecules in the thermosphere, creating colorful patterns that dance across the sky. The thermosphere also plays a key role in space exploration, as it is where the International Space Station orbits the Earth. Finally, the outermost layer of the atmosphere is the exosphere, which gradually fades into the vacuum of space. The exosphere extends from about 600 kilometers above the Earth to roughly 10,000 kilometers. In this region, the atmosphere is extremely thin, and particles of gas are so sparse that they can travel hundreds of kilometers without colliding with one another. This is the realm where satellites orbit and space travel begins. The atmosphere, while invisible to the naked eye, is far from static. It is constantly in motion, driven by the energy from the sun and the Earth's rotation. These movements create wind patterns, weather systems, and even large-scale climate patterns that shape the environment in which we live. One of the most important processes in the atmosphere is the transfer of heat from the equator to the poles. Because the equator receives more direct sunlight than the poles, the air near the equator is warmer and rises. As it rises, cooler air from the poles moves in to take its place, creating wind patterns that help distribute heat around the planet. This process, known as atmospheric circulation, is responsible for the trade winds, the jet stream, and other wind patterns that influence weather and climate. The atmosphere's circulation is also linked to the formation of weather systems like cyclones, hurricanes, and thunderstorms, which occur when warm, moist air rises and cools, leading to the formation of clouds and precipitation. The atmosphere not only affects weather but also plays a crucial role in regulating the Earth's climate. One of the key components of this regulation is the greenhouse effect. The Earth's surface absorbs energy from the sun and then radiates it back into space as heat. However, certain gases in the atmosphere, known as greenhouse gases, trap some of this heat and prevent it from escaping. This process keeps the Earth warm enough to support life. Without the greenhouse effect, the average temperature on Earth would be around -18 degrees Celsius 0 degrees Fahrenheit, making the planet too cold for most forms of life. The most important greenhouse gases are water vapor, carbon dioxide, methane, and nitrous oxide. While these gases are naturally present in the atmosphere, human activities such as burning fossil fuels, deforestation, and agriculture have significantly increased their concentrations. This has enhanced the greenhouse effect, leading to global warming and climate change. As the planet's temperature rises, the atmosphere responds in ways that affect weather patterns, sea levels, and ecosystems around the world. One of the clearest signs of how the atmosphere is changing due to human activity is the increase in extreme weather events. Hurricanes, droughts, heat waves, and heavy rainfall are becoming more frequent and intense, as the atmosphere holds more energy and moisture. These changes are not only affecting the environment but also impacting human societies, from agriculture and water supplies to infrastructure and health. The Earth's atmosphere is also influenced by external factors, such as volcanic eruptions and solar activity. Large volcanic eruptions can release vast amounts of ash and gases into the atmosphere, which can temporarily cool the planet by blocking sunlight. Similarly, fluctuations in solar radiation can affect the atmosphere's temperature and circulation patterns, leading to changes in climate over long periods of time. Throughout history, the atmosphere has been shaped by both natural processes and human actions. In recent years, scientists have gained a deeper understanding of how the atmosphere works, thanks to advances in technology and satellite observations. This knowledge is helping us to better predict weather, understand climate change, and develop strategies to protect the environment. The atmosphere is more than just the air we breathe. It is a dynamic system that connects all living things on Earth. It acts as a protective shield, a regulator of temperature, and a medium through which life can thrive. From the swirling winds of the troposphere to the glowing auroras of the thermosphere, the atmosphere is a vital part of the Earth's complex and interconnected systems. As we continue to study and explore the atmosphere, we gain a greater appreciation for its role in sustaining life and its vulnerability to the changes we are making to the planet. In the end, the atmosphere is a reminder of the delicate balance that exists between the Earth and the forces that shape it, and the responsibility we have to protect it for future generations.